Hey everybody, it's Mark Gamble again. Made some improvements to the idea for the floating wind farm raft, and they're sort of way out there as far as what I was thinking of comparatively. This is after some of the criticisms that I got. I figured a way of improving the wind farm design. Now, what this is based off of is the idea of like really elongated buoys, and that's what those yellow bits there are, that are basically able to bend in the middle and in certain parts to move the mechanical shake in different directions. Now this is based off of the size of the buoys is based off of calculations I made that were in the last floating wind farm film that was released only about like maybe a week ago. Basically, water, seawater is 1/6 as heavy as steel, and polyurethane is 1 ton lighter than seawater per cubic meter. So what you have here is the ratio of cubic meters of polystyrene that it would take to equal 1 cubic meter of steel. And I've got this for the theoretical 10 megawatt range of towers, which don't actually exist yet, but I'm looking at like the ahead engineering here. It says that basically the leg joints of this would have to be about 42.5 meters is what I estimated for the length. And so therefore, if you're to get the correct amount of buoyancy that you'd need to the amount of steel for the 10 milliwatt range, you would need a buoy that is roughly 42.5 meters long. And there are 6 of these on the design. I could show you later. And 2.25 by 2.25 meters height and width. And that would equal out enough polystyrene with the scheme to actually load this out and make it so that it would equal out in buoyancy. This is more or less just to show you how that would look. There's a cut mark in the middle of it. And to give you a close-up view, this isn't everything about the buoys, but this is just like giving you an idea of the size that it would take to do 10 milliwatts by 10 milliwatts. Now this system is just or a lot like the floating raft system that I was talking about in the last one. I don't have it quite done, like I haven't figured out everything mechanically you'd have to do, but this is sort of an overview of how it would look. Now, the thing about this is that any tension on one part of this tower system is going to try to force the joints down and around, which the joints of the buoy system are already in tension. They're in floating up tension. So basically, anytime the tower moves, it basically tries to move the buoys, which are already in tension against it. So it's trying to move like thousands of pounds or tons instead of free floating. And this is a breakdown of basically the key that I have for this at the moment. See, this is an example of what I was talking about. Now, if you look at this, I have in red like sort of the forces of weight from the towers, and in green the counterforce of the buoys. And the buoys, once they go away from the towers, want to lean up. So therefore, to have those buoys go down on both sides would mean that you're countering the buoyancy force of the buoys. Now, you'll still need masts in this case, and you'll need them on like the outside to make an absolute limit for how far the buoys can wander. But on top of that, the more important part, I think, is that you could use these buoys as sort of a mechanical shock absorber if you have it set up right. These little green marks here are really more supposed to represent the idea of there being a stoppage in the buoy system where it becomes more of a flow mechanics machine. Like this is, like you just have pegs that connect them so they can move slightly. The idea is more like you mechanically you create a space where you're using water flow in and out of and this different type of joint you could make. None of these have really been tested yet. These are all just kind of ideas at this point. But that you can use water and forcing water in and out of the joint mechanically to become a better buffer zone and create a loose joint in one place where you want it to shake, and make it so that the towers, which in this model don't have any buoyancy and therefore have less mechanical shake because they're not carried by the waves, help it mitigate that shock from the wave. So this is another concept. Even is you could take and just make a really elongated piece and have it shake up and down and move water out that way and create sort of a small pump system. And all of this is going to have to be like connected with cable, which is one of the things not pictured in this. There's probably going to be a video later that explains more of the ins and outs of how that would work. But basically, just consider it that there's a long cable running through these buoy systems that connects the buoy system to the tower. For right now, I don't know if that's like a definite design detail, but could be. There's a lot of ways to skin a cat. And this idea only came to me maybe like 4 or 5 days ago, or a little less than that, 3 or so days ago maybe. And I'm gonna keep working on it. I've got some people who will let me use their AutoCAD system, and maybe even someday access to a wave machine pretty soon. I think I know how. I think it would be pretty easy actually to make a working model of this, and that's one thing I'm gonna go after as I refine this back. Well, I hope if anybody saw the other video with the other type of raft system, you understand that it's like a moving design. A lot of people said that they just thought that the material cost was way too much. And so this is my attempt at getting the material costs down for a system that would never actually have to touch the surface of the seafloor. Alright, well, I hope you have a great day, whoever you are. Thanks for your time. Bye.